let me explain the concept of the pointers in C++. I'll show you by using the live C++ program with Visual Studio Code. So let's begin with creating a folder or project in the Visual Studio Code. For Explorer, open folder, locate some place you want to create a new project. This is a Mac, so you see the new folder button to create a new folder, but Windows you will not see this part. So instead place the cursor over inside this area and then do right click and then choose a new and folder to create new folder. So new folder, let me name it as a pointers, create that, and then open it. Now I'm inside the prom pointers folder. Now let's create first the file exercise1.cpp. At this moment, I want to configure Visual Studio Code for C++ debugging. So if you change the mode to debug, at first you will see no configuration. So I want to configure this one first. Refer to the earlier video. Depending on Windows or Mac, how to configure is different. So I'm going to pause the recording, and also I want you to pause the video and then configure it and then come back. Now I have configured for debugging on Mac, so I see LLDB launch, but if you're using Windows, you should see GDB launch for that. Let me go back to the File Explorer. Now let's create the program. Include IOStream using namespace. So let me first define an integer variable n with a value of 10, double variable d with a 1.2. Now let me compile the program for debugging. So let's open a terminal, view, terminal. Be sure to compile with the -g option. That's for debugging symbol generation as well. Compile that. Then let me add the breakpoint at line 5. Go to the debug mode. Start debugging. Program execution pauses at line 5. Since it's not executed yet, the value of n is meaningless. If I do step over, n is initialized, but d is not yet. So at this moment, I have created two variables, n and d. 6 is not executed yet though, but when you define a variable, the variable is physically a storage in the memory, and the storage has three properties. So line 5 is just executed, so we have a variable named n. So this is storage, is where you can store something. And the variable name is something like a label of the storage, just imaginary, it's not physical thing. So variable name corresponds to label of the storage. Variable is storage there. So storage, one property is name or label. We define that in this code. And another property is a value of the variable, a value stored in the storage. So there is a value. It's the second property. How to set some value, store some value, we have assignment operation. So those are two properties of a variable. And there is another property, that is the location of this storage, where it is created inside the computer memory. So we can take a look at the location information in C++ with a special operator. So if you choose on the downside of the Visual Studio Code, there's a debug console tab. On the very bottom, there is a angle bracket console where you can run some of the C++ commands in this debugging mode at this moment. For example, in this debugger console, if I just give a name of the variable n, then the value 10, you can see that on debugger console. Of course, if I do D, then scroll it down, the value is a very little tiny because the line 6 is not executed yet, so whatever is in D is meaningless. So the third property of a variable is a location, and C++ that is called the address of the variable. So from the debugger console, we can get the address of a variable n, which is the location, with a special operator called ampersand and then n. Then this gets you the location of a variable n, which is address of a variable n. This address is allocated by your computer operating system automatically. It is it looks like a number in hexadecimal format. So the value appears to be an integer kind of a value, but in C++, this is not of a type integer. It has a special type called address type. So apparently like integer, but it's not an integer inside the C++ program. So that is a address type. So at this moment, if I step over, now line 6 is executed, D gets 1.2. Now I can do ampersand D, and that is address of a variable D. So you can see that this is address of a variable n, this is address of a variable d. Those are different because physically a variable d is created some other place, not sharing with the n at all. So pointer is, let me stop the debugger. Pointer is, in C++, pointer is also called a pointer variable. It's a special variable, special type of variable where you can store address of other variables. So pointer is a variable, but the contents are, so what you can store in the pointer is address only, not integer, not double, not character, just the address of other variable only. That's the definition of a pointer in C++. So pointer is a variable, bottom line, and then what you can store is address only. So in debugger console, we have learned that I can get address of a variable n by using ampersand. Then I get the address. I want to store the address into variable p. Then C++ syntax is variable p equal address of n. That is the one. But before you use the variable, I need to define first. So p, how do I define? That is the C++ grammar. So remember that to store address of other variable, we need a pointer. Pointer is to store address of other variable. Pointer is just a variable, like that. But how do we declare a pointer variable? Before the name of the variable, give a star. So, and before the star, you need to specify if you go to the address. So in P, an address is stored. If you go to that address, what type of value you are going to see. So the purpose of a P here is to store address of n. So P is holding address of n. If you go to the address, you will meet the variable n. And then variable n, what type of variable is that? That is an int type. So that's how to declare a pointer. In C++, space is not part of the grammar. So here something like you can do this way or that way, or you can give many spaces. That's not a part of the grammar. So here, without space at all, this is a valid syntax, but for readability, we use a blank after the star. So when you see something like int n, we know that int is a type of n. So when you see something like that, what is a type of a p? Integer address type. So star is a meaning for address. So p is an integer address type. So this is a valid C++ program so far. So what's happening inside the computer memory is as I declare int star p, I create variable named p exactly the same way variable n is created. However, in this storage, you can store is address of other variable like n, not integer 10 or 20 and the like. So let's examine what is actually inside the p in this program. So let me go back to terminal. Since I have changed the source program, I need to recompile the code and then I can use the debug again. So debug mode, start debug at line 5. Let me do step over, step over, step over. Then all of those programs are executed. So in the variable p, what I have is those value now as I executed a line 9, and then go back to debug console. Address of n is this value. So if you compare address of n here and then what is stored in variable p, same thing. That's because I have assigned that way. So pointer is to store address of the other variable. Let me stop the debugger. And then if I try to store in p the value like integer, then it says error. There is a value of a type int cannot be assigned to entity of type int star. Int star is address. So p is to store address, but 1243 is integer, so we have a assignment error there. Then once you have address, and then C++ has some interesting operator. So let me define int b, and then into b I can assign a value from what the pointer p is pointing. So pointer p is holding address of n, but if I give a star prior to the pointer, so this is called indirect operator. Indirect operator is a star, is that the address we have and then we move there and then get the value. That's indirect operator. So what we'll do here is currently p is holding address of n, and star means go to that address. Then it is n. So you read the value from n and then store it into b. So let's go back to the terminal, compile it again since I've edited the code, start the debug. So at this moment, no statement says executed. All the values are meaningless. Step over, n gets a 10. Step over, d gets a 1.2. P is not initialized yet, but if I do step over, p gets address of a variable n. Actually, the debugger, you can unfold the p, then star p. P is address, and if you move there, star indirect operator, then what you see is a 10, which is the same of a variable n there. So B, if I do step over, you read from what P is pointing, which is a variable n, and then you get the value B like this one. Let me stop the debugger and let's do another one. So at this moment, let me do this way. Star P is 55. So what it does is same meaning. So here is indirect operator star. So you move to where P is pointing to. P is pointing to variable n. So this is same as variable n. So this is actually same as n assignment 55. So variable n gets changed. So let's verify that. Terminal, compile, start the debug. Variable n, step over, and over. So n is 10. Now P is holding address of n, so line 11, if I execute, n will change to 55. There, indirectly. So that's we have an indirect operator. And then if we read from star P, which is 55. Also, you can read from n is 55. So this is the very basic concept of a pointer, and then this applies to any type. Let me explain the double type in the next video.